this section, we're going to look at basic steps in calculating a probability and identifying key components and terms in a probability language. So to do this, we're going to start with practice problem. This is number 26 on page 146 in your book. Here we're looking at the Y-sort technique. So we're looking at the likelihood of having a baby boy. So we have some data here. We have 291 births. Of those, 239 were boys and 52 were girls. So we want to look at what is the probability of having a baby boy using this Y-sort technique. And we also want to answer the question of whether or not it appears to be effective. Now to do this, we can see over here on the whiteboard setting up the problem. So P of A here is the event birth of a baby boy. That's what we're interested in. And you can see we've got the formula here already. So we're going to use the number of times A occurred, and we're going to divide it by the number of times the procedure was repeated. So working with the data we have here, take a few moments and look at this and think how you'd plug the data in. And then let's proceed to the next slide and check it together. All right, so 239 is going to be the number of times a baby boy was born, and 291 is the total number of births. So we take 239 divided by 291, and we get 0.82130584. Now, we need to apply our rounding rule here. So our rounding rule is going to 3 decimal places. So applying our rounding rule to this problem, we then get our final answer of 0.821. So that is the probability of having a baby boy using the Y-sort technique. Now, we need to ask ourselves, does this technique appear to be effective for increasing the likelihood of a baby boy? Again, we'd be comparing this back to the probability of having a baby boy without any intervention, which would be 0.50. So we make that comparison, we can see that yes, this value is much greater than the 0.500 probability without any intervention, so we can say the technique is effective. So this is the basic steps in calculating a probability. And now we're going to take this formula in the scenario and go through and use it to help us identify some key other components for when we're talking about a probability. So, basic terminology here. First of these is an event. An event is the result or outcome of any procedure. So whether or not we were having the birth of a child, as we use the example here, or any other particular example we'd want to look at. For example, we'll be looking at the odds of selecting certain individuals from a particular population. That selection would be the event. So an example of event, looking here, we can see that a single birth, so the birth of a girl would be a simple event. If we were looking at a procedure that involved 3 births, so if we were looking at 3 consecutive births, we would have procedures that would be 2 boys and 1 girl. That would be one possible outcome. Now, notice the simple event is an outcome that cannot be broken down into simpler components. So here, again, for the single birth, the birth of a single girl, that is the simple event. Okay? Now, when we start having more events, when we start having more complex procedures, such as 3 births, we can see that we can actually have several different simple events that would all result in 2 boys and 1 girl. So you could have the order of a baby birth of boy, boy, girl. You could have boy, girl, or girl, boy, boy. So any of these 3 are simple events resulting in 2 boys and 1 girl. So notice when you're looking at this, that for probability problems, there's only 2 possible outcomes, like birth of a boy or a girl, so a basic dual thing. The event and the simple event are the same. However, when you start moving into 3 or more possible outcomes, they become very different. Lastly, we need to look at the sample space. Now, the sample space is all possible simple events. Now, notice here that the sample space includes all possible simple events, including the outcomes we are not looking for, but could still occur. So looking at the single birth, we can see that the sample space would consist of both the birth of a baby boy and the birth of a baby girl, since both of those are possible. So the sample space is not the same thing as a simple event. So be clear in that in your terminology to make sure that when you're solving a problem, you're clear about what they are asking for. Again, notice also looking at the 3 births, the sample space includes all possible arrangements of birth for 3 children, 2 of which are boys and 1 of which is a girl. So this concludes our section on looking at the basic concepts of probability. Make sure you are clear about this language when we talk about an event, a simple event, and a sample space, and be clear about what they are, how they are related to each other, and also how they are different, so that when you encounter this language in future problems, you'll be able to use it appropriately.